In this video, we will be doing lesson 4-3, part 1, where we do half of the notes and we focus on prime factorization. So there will be some parts that we skip that will be in the video lesson 4-3, part 2. So today we're going to be talking about prime factorization. So in order to do that, we need to define what a prime number is. A prime number is a positive integer greater than 1 with exactly 2 factors, 1 and itself. So if you were to try to divide a prime number, you can only divide it by 1 and itself. It doesn't get divided by anything else. Okay, a composite number is a positive integer greater than 1 with more than 2 factors. So basically, there's 2 choices. A number is either prime or it's composite. Okay, so if it only has 1 that goes in itself that goes into it, it's a prime number. If it has more than that, it's going to be a composite number. So let's make a list just of like the first few prime numbers because that will help us with today's assignment. So it has to be greater than 1, so we're going to start at 2. The only thing you can put into 2 is 1 and 2, right? Then we have 3. The only things you can put into 3 are 1 and 3. We skip 4 because you could put a 1, a 2, or a 4 into 4. Okay, so it has more. So you see how the pattern's working? So we have 5, 7, then we skip all the way up to 11, 13, 17, and 19. Those are the first few prime numbers. So those will be helpful as we're making factor trees today because you'll need to use prime numbers to do that. The prime factorization of a number is a written form of a number as the product of its prime factors. So essentially, we're going to take numbers and we're going to break them into only prime numbers being multiplied together to get to that number we started at the beginning of. So we're going to make little trees where we break apart the number into pieces and we have a list of prime numbers, and that's the prime factorization. Okay, since this is part 1, we're going to skip that next definition because that'll be part of part 2. So this next part says prime or composite. State whether each number is prime or composite. So we're trying to figure out if it has more than 1 factor, 1 in itself, or if it has just 1 in itself. So 46. If I were to look at 46, 46 could be divided by 2, and that would be 23, right? So that means that 1, 2, 23, and 46 all go into it. Since that's more than just 1 in itself, that means that it's going to be a composite because it has more than 2 factors. Okay, 13 we already listed as a prime number up at the top, right? So 13 is prime because the only numbers that go into it are 1 and 13, meaning it has exactly 2 factors. Okay, so some of the questions on the homework are just going to be, is it prime or is it composite? How do you know? And this is how you would do that. So I've been mentioning that we were going to work on factor trees. So the way that works is you put the original number up at the top. So they said write a factor tree for the prime factorization of 273. So at the very top we have 273. breaking off of that, we always start at 2 and work up with prime numbers. So what that means is the first thing you're going to do is you're going to try and put 2 into a number. Can you put 2 into 273 and have an even number? The answer is no, right? Because it's an odd number. Can you put 3 into it? Yes. 3 times 91 is 273. So we broke it apart. So we have a prime number over here, and then we have a number that we're going to be able to break apart again that we're timesing it by. 91 is going to break apart. If we try 2, it doesn't work. 3 doesn't work. 5 doesn't work. 7 times 13 gives us 91. So now we have all prime numbers, 3, 7, and 13. So that means that we're done because prime numbers can't be broken apart like this. So then to write your actual prime factorization, you write that list of prime numbers. So you say 273 equals 3 times 7 times 13. Because I take the ends where nothing has been broken off from them, and those are the numbers that I use to list for my prime factorization. All right, so when you're ready, go ahead and turn your paper over. So we're going to skip these parts because that's going to be part of part 2, and we're down here now at the quick check. Which numbers from 10 to 20 are prime? Okay, so referencing that list on the front page, go ahead and pause the video, and you can do A and B. You're going to list out the prime numbers, and then you're going to list out the composite numbers between 10 and 20. So pause the video and go ahead and do that. All right, so hopefully what you wrote for that, for A, was 11, 13, 17, and 19 are the prime numbers between 10 and 20, which means that for composite, you should have had 10, 12, 14, 15, 16, 18, and 20. All right. I'm going to do A here with us, practicing writing out our prime factorization, and then you will pause the video and work on the other ones as we go. So 72. So the first thing we do is we write 72 at the top of our tree, and we're going to break it apart. 72 can be broken apart to be, if we did a 2, right, because where we start at 2 and try that first, 72 divided by 2 is 36. So we would say 2 and 36 are the ends of the trees. 36 can be broken apart. Again, we start with 2. 2 goes into that, so we're going to have 2 times 18. Break apart the 18. Can we put a 2 into that? We can. 2 and 9. Break apart the 9. Can we put a 2 into that? No. So we're going to have 3 times 3. Okay, and now we're at a point where we only have prime numbers. Oops, that's huge. Prime numbers on the ends that are not broken apart. So then to write our prime factorization, we're going to say prime factorization equals 2 times 2 times 2 times 3 times 3. Right? And then we could also say prime factorization equals, using our exponents that we've learned, 2 to the third times 3 to the second. Okay, so both of those are the answer. So the first way you write it out is with them listed. The second way you're going to write them with the exponents. All right, so go ahead and try B and C and then stop. And we'll check those together, and then we'll do D as well. So do B and C with the video paused, and then come back and let's see if we did them the same. All right, so hopefully what you did for 121 was test all your numbers starting at 2 for primes. 2, 3, 5, 7, and none of those worked. But 11 worked. 11 times 11. So then you're done because those are both prime numbers. So you would just say prime factorization equals 11 times 11. Prime factorization equals 11 to the second power because there are 2 of them. Then for 225, we would break that apart to be 3 and 75. 75 can break apart to be 3 and 25. 25 breaks apart to be 5 and 5. So we would say prime factorization equals 3 times 5 times 5. Or prime factorization equals 3 to the second times 5 to the second. All right, beautiful. So now if you got both of those correct, or if you didn't, hopefully you figured out where you were going wrong, let's try D. So go ahead and pause the video and do D, and then we'll come back and we'll all go over it together. All right, so hopefully what you got for D, 236, and we break it apart. It's an even number, so we start with 2 times 118. That's an even number again, so we can use 2 and 59. You might have struggled a little bit here. 59 is in fact a prime number. So this is as far as you can go. So you have prime factorization equals 2 times 59. Prime factorization equals 2 to the second times 59. All right, so that's it for part 1 of lesson 4-3 on prime factorization.